2020 National Electrical Code, or NEC, requires all outlets in bedrooms to be on arc fault circuit interrupter, or AFCI protection. This requirement is in place to reduce the risk of electrical fires caused by arcing faults. A ground fault circuit interrupter, or GFCI, is a safety device that protects against electrical shocks by cutting off power when a ground fault is detected. The term dead front GFCI signifies that the reset and test buttons are protected by a faceplate, making them less accessible. When considering a dead front GFCI for a whirlpool located just outside a bathroom door, several aspects need to be addressed. Firstly, the GFCI provides protection from electrical shocks for the whirlpool. Secondly, if the GFCI is located outside the bathroom door, it is generally not considered an outlet in the bedroom. Therefore, it does not necessarily need to be on AFCI protection. Thirdly, all other outlets within the master bedroom must be on AFCI protection, as mandated by the NEC. It is recommended to maintain the faceplate of the dead front GFCI closed to prevent any accidental tripping or tampering. You should regularly test the GFCI by pressing the test button to ensure it is functioning correctly. If the GFCI fails to trip when the test button is pressed, it indicates a malfunction and the device should be replaced immediately. For additional safety and compliance, you can consider these further points. 1. Ensure all AFCI breakers are correctly installed and tested according to the manufacturer's instructions. 2. Be aware of the specific requirements for AFCI protection in your local jurisdiction, as they may vary slightly from the NEC. 3. When selecting AFCI and GFCI devices, choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertech, to ensure they meet safety standards. 4. Consider using combination AFCI/GFCI breakers to provide both arc fault and ground fault protection in a single device, especially in areas where space is limited. 5. Educate occupants about the purpose and function of AFCI and GFCI devices and how to test them regularly. 6. Keep electrical panels accessible and clearly labeled for easy identification of circuits. 7. Avoid overloading circuits by plugging too many devices into a single outlet or circuit. 8. Inspect electrical cords and plugs regularly for damage, and replace them if necessary. 9. Use surge protectors to protect sensitive electronic equipment from voltage spikes. 10. Be cautious when working with electricity, and always turn off the power at the breaker before performing any electrical work. Further elaborating on AFCI protection, it's important to understand the types of arc faults they are designed to detect. There are primarily two types. Firstly, series arc faults, which occur when a wire is broken or damaged, interrupting the flow of current, and secondly, parallel arc faults, which occur when there is a short circuit between two wires. AFCI breakers are designed to detect these arc faults and trip the circuit, preventing electrical fires. Regarding GFCI protection, it's crucial to recognize the different types of GFCIs available. There are firstly receptacle-type GFCIs, which are installed in place of a standard electrical outlet and provide protection for the specific outlet. Secondly, circuit breaker-type GFCIs, which are installed in the electrical panel and protect the entire circuit. And thirdly, portable GFCIs, which can be plugged into an outlet and provide temporary GFCI protection. It's also beneficial to understand the differences between AFCI and GFCI protection. AFCI protection is primarily designed to prevent electrical fires caused by arcing faults, while GFCI protection is designed to prevent electrical shocks caused by ground faults. Although both types of protection are important for electrical safety, they serve different purposes. When installing AFCI and GFCI devices, it's essential to follow the manufacturer's instructions carefully. Incorrect installation can compromise the effectiveness of these safety devices. Also, ensure that you are using the correct type of AFCI and GFCI devices for your specific application. For example, some AFCI breakers are designed for use in specific types of circuits, and using the wrong type can lead to nuisance tripping. When testing GFCI devices, it's important to perform the test correctly. Press the test button on the GFCI device. The device should trip, cutting off power to the circuit. If the device does not trip, it indicates a malfunction and the device should be replaced immediately. Also, after testing the GFCI device, be sure to reset it by pressing the reset button. It's also essential to understand the limitations of AFCI and GFCI protection. These devices are not foolproof and may not protect against all types of electrical hazards. It's crucial to practice safe electrical habits and to have your electrical system inspected regularly by a qualified electrician. Regarding specific requirements for AFCI protection in bedrooms, the NEC typically requires AFCI protection for all 120 volts, 15 amps and 20 amps branch circuits supplying outlets in bedrooms. This includes lighting outlets, receptacle outlets, and any other type of outlet that supplies power to devices in the bedroom. In addition to the general requirements for AFCI protection in bedrooms, there may be additional requirements for specific types of circuits or locations. For example, some jurisdictions may require AFCI protection for circuits that supply smoke detectors or carbon monoxide detectors. It's essential to check with your local electrical inspector to ensure that you are meeting all applicable requirements. When selecting AFCI breakers, it's important to choose products that are compatible with your electrical panel. AFCI breakers are available in different sizes and configurations, and it's essential to select the correct type for your panel. Also, consider the interrupting rating of the AFCI breaker. The interrupting rating is the maximum amount of current that the breaker can safely interrupt in the event of a short circuit. Choose a breaker with an interrupting rating that is appropriate for your electrical system. When installing AFCI breakers, it's essential to follow the manufacturer's instructions carefully. Incorrect installation can compromise the effectiveness of these safety devices. Also, be sure to test the AFCI breakers after installation to ensure that they are functioning correctly. In addition to AFCI and GFCI protection, there are other important electrical safety measures that you should take to protect yourself and your family. These include, firstly, using properly grounded outlets and extension cords, secondly, avoiding overloading circuits, and thirdly, keeping electrical cords and appliances away from water. By following these simple safety tips, you can significantly reduce the risk of electrical hazards in your home. For example, when using extension cords, be sure to use cords that are rated for the amperage of the devices that you are plugging into them. Overloading extension cords can cause them to overheat and potentially start a fire. Also, when using electrical appliances near water, be sure to use GFCI protected outlets. This can help to prevent electrical shocks if an appliance falls into the water. It is imperative to remember that electrical safety is an ongoing process. Regular inspections and maintenance are crucial to ensuring the continued safety of your electrical system. Consider scheduling periodic inspections by a qualified electrician to identify and address any potential issues before they become major hazards. For instance, during these inspections, the electrician can check for loose wiring, damaged outlets, and other problems that could compromise the safety of your home's electrical system. Additionally, it is important to stay informed about the latest electrical safety standards and best practices. The NEC is updated every 3 years, and it is essential to be aware of any changes that may affect your home's electrical system. You can find information about the NEC and other electrical safety resources online or by contacting your local electrical inspector. In addition to regular inspections, it is also important to perform routine maintenance on your electrical system. This includes tasks such as replacing worn or damaged outlets, tightening loose wiring connections, and trimming trees that are growing too close to power lines. By performing these simple maintenance tasks, you can help to prevent electrical hazards and extend the lifespan of your electrical system. When performing any electrical work, it is crucial to take the necessary safety precautions. This includes turning off the power at the breaker before working on any electrical circuits, wearing appropriate personal protective equipment such as gloves and safety glasses, and using insulated tools. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician. When it comes to electrical safety, it is always better to be safe than sorry. Taking the time to implement proper safety measures and staying informed about the latest electrical safety standards can help to protect you and your family from the risk of electrical hazards. Remember that electricity is a powerful force and it should always be treated with respect. By following these guidelines, you can ensure that your home's electrical system is safe and reliable. Furthermore, let's delve into the specific nuances of AFCI and GFCI technology to provide a more comprehensive understanding. AFCIs, in particular, employ sophisticated algorithms to differentiate between normal arcing that occurs during the operation of certain appliances, such as a motor starting, and dangerous arc faults that indicate a potential fire hazard. These algorithms analyze the current waveform for specific characteristics that are indicative of arcing, such as irregular spikes and high-frequency noise. GFCIs, on the other hand, operate on the principle of detecting imbalances in the current flowing through the hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. However, if a ground fault occurs, some of the current will flow through an unintended path, such as a person's body, creating an imbalance. The GFCI detects this imbalance and quickly trips the circuit, cutting off power and preventing electrical shock. When selecting AFCI and GFCI devices, it is crucial to consider the specific requirements of the application. For example, in kitchens and bathrooms, where moisture is present, GFCI protection is typically required for all outlets. In bedrooms, AFCI protection is required for all outlets, as mentioned earlier. Additionally, certain appliances, such as dishwashers and washing machines, may require dedicated circuits with both AFCI and GFCI protection. It is also important to consider the environmental conditions in which the AFCI and GFCI devices will be installed. For example, in areas with high humidity or corrosive substances, it is important to choose devices that are specifically designed for those conditions. These devices typically have corrosion-resistant housings and other features that protect them from the elements. When installing AFCI and GFCI devices, it is crucial to follow the manufacturer's instructions carefully. Incorrect installation can compromise the effectiveness of these safety devices and may even create a fire hazard. It is also important to use the correct wiring method and to ensure that all connections are properly tightened. After installing AFCI and GFCI devices, it is important to test them regularly to ensure that they are functioning properly. The test procedure typically involves pressing the test button on the device, which should cause it to trip. If the device does not trip, it indicates a malfunction and the device should be replaced immediately. In addition to testing AFCI and GFCI devices, it is also important to inspect them periodically for any signs of damage or wear. This includes checking for cracked or broken housings, loose wiring connections, and other problems that could compromise their effectiveness. If any damage is found, the device should be replaced immediately. To further enhance electrical safety in your home, consider implementing the following additional measures. Firstly, install smoke detectors on every level of your home and test them regularly. Secondly, have your electrical system inspected by a qualified electrician every few years. Thirdly, use surge protectors to protect your electronic equipment from voltage spikes. Fourthly, avoid using extension cords as a permanent wiring solution. Fifthly, keep flammable materials away from electrical outlets and appliances. Sixthly, never overload electrical circuits. Seventhly, be careful when working with electricity near water. Eighthly, teach children about electrical safety. Ninthly, be aware of the signs of electrical problems such as flickering lights, burning smells, and sparking outlets. Tenthly, if you experience any electrical problems, contact a qualified electrician immediately. By implementing these additional measures, you can create a safer electrical environment for yourself and your family. Remember that electrical safety is an ongoing process, and it is important to stay vigilant and proactive in order to prevent electrical hazards. The NEC serves as a cornerstone for electrical safety, providing comprehensive guidelines and requirements for the installation and maintenance of electrical systems. Staying informed about the latest updates to the NEC is crucial for ensuring that your home's electrical system meets the highest safety standards. Consult with a qualified electrician to ensure that your electrical system is in compliance with the NEC and any applicable local codes. In summary, AFCI and GFCI protection are essential components of a safe electrical system. By understanding the principles behind these technologies, following proper installation and testing procedures, and implementing additional safety measures, you can significantly reduce the risk of electrical hazards in your home.